Okay, so here I'm just gonna give you a few tricks on matrices and determinants and give you a key size idea behind this. Let's say maybe we have a matrix, a 2 by 2 matrix. Let me just start with that one because it's simple. So let's say we have 2, 3, minus 2, and 1. If we have this matrix like this, and we were to evaluate the determinant of that matrix, we're basically going to have 2, 3, minus 2, 1, and then this is basically going to be, if you use the diagonal rule, then you're going to have 2 by 1, minus 3, multiplied by minus 2, and this will basically simplify to 2 plus 6, which just gives you 8. But now, let's say you don't want to use the diagonal rule on this. Keep in mind that for every matrix, the odd numbers are always associated with the negative sign and progressing like that. So now this basically means plus, minus, plus, and minus like that. So you can also use like expansion along a column as well. Then if you use an expansion along a column, you're basically going to have 2. Then you're basically going to have to multiply it with this one here. And then since this one is associated with a positive, then you have positive and you have minus 2, and then you multiply that by 3. So that's going to give you like, so since like this one is odd, for 3 it's odd, you're going to have minus 3. That's if you use like an expansion along a column, along the first column, that is. So you're going to have 8 as well. Or since you're basically looking for this determinant, the key size idea that you have to know is like using row operation on or extremely like kind of like changing one row doesn't really like affect anything. So we can basically say since we're looking for determinant of A, and it's basically 2, 3, minus 2, and 1, we can basically replace, if we replace row 2 with row 2 plus row 1, if we replace row 2 plus row 2, let me just write it down, replace row 2 with row 2 plus row 1, you're also going to get the same determinant. So we keep row 1 the same, and then row 2 plus row 1, it's going to be minus 2 plus 2, which gives you 0, and then we have 1 plus 3, which gives you 4. And if you were to evaluate that determinant, you're also going to get 8, because it's 2 times 4, which gives you 8, and then you have minus 3 by 0, which just gives you 0. Then you end up with that determinant basically being 8. And now this skill here of manipulating rows, we end up having to use something called a row echelon form. A row echelon form. So for this one, we're basically going to use the diagonal to like evaluate the determinant. Let's say maybe we have matrix A, 3 by 3 matrix. Let's say it's 1, 2, 5, 6, 7, 1, and then 3, 4, let's say 2. Let's say we have a 3 by 3 matrix like this. So now what we want is to find the determinant of that. So at first you can do that using the diagonal rule, but you can also like use row echelon form to manipulate that. Remember, manipulating or changing rows with using row operations won't really like affect the determinant. So we can then say replace okay, let's start by obtaining a 0 here. We can say replace row 3 with row 3 minus 3 row 1. If we do that, then we're going to obtain a 0 here. And then if you want to obtain a 0 here, we can say replace row 2 with row 2 minus 2 row 3. And then let's just keep row 1 the same. So it's just 1, 2, 5. And then replacing row 2 with row 2 minus 2 row 3, so it's going to be 6 minus 2 by 3, which is just going to give you 0. And then we have 7 minus 2 by 4, which is just going to give you minus 1. Since 4 times 2 is 8, then you have 7 minus 8. And then you have 1 minus 4, which is just going to give you minus 3. And then here we replace row 3 with row 3 minus 3 row 1. And then this means that you're going to have 3 minus 3 times 1, which is just going to give you 0. And then we have 4 minus 2 by 3, which is just going to be minus 2. And then you have 2 minus 15, which is just going to give you minus 13. And then from here we basically obtained 0 0 here. We only need the final 0, which is here. So to obtain a 0 here, we can then say for replace row 3 with row 3 minus 2 row 2. So that way we keep row 1 the same, 1 2 5, and then we have 0, and then we have 0, and then that's because 0 minus 2 by 0 is still gonna be 0, and then now we have minus 2 times negative 1, which is just gonna be minus 2 plus 2, which is just gonna give you 0. And then row 3, it's minus 13 minus into negative 6, so that's just gonna be plus 6. Minus 13 plus 6, that's just gonna be 7, minus 7 I mean. And then we didn't change row 2. So now that you obtain a row echelon form of this, the determinant of A, remember A is this matrix, but the determinant of A will be the same as, since you obtain a row echelon form here, you're just going to multiply this. So it's going to be 1 times minus 1 times minus 7. So that's just going to be minus 1 by minus 7, it's 7. Multiply that by 1, then you get 7. So that's how you can get the determinant of that. That's how powerful row echelon form is. So you can basically obtain row echelon form and just multiply the diagonal like that. Okay, so let's look at this matrix here. So here we can see that here we have multiples of 3 and we have a negative sign here. So we can basically, if we're looking for the determinant of B, let me just write it down in determinant form: minus 12, 6, 11, and 9, and 3, 6, and 5. So we can basically take out effect of minus 3 in the upper row like this. So let's do that. Then we have minus 3 multiplied by the determinant of this divided by minus 3 is going to be 3. And then this one you'll have 4 and 4 like that. Then you have 6, 11, and 9, and 3, 6, and 5. So now we have something like this. Now we want to obtain a row echelon form, so we can be able to find the determinant of that. And then we can just basically say replace row 3 by row 3 minus row 2. And when we do that, we obtain 3 minus 3, which gives us 0 here. Then here we get 2, and then here we get 1. Now we want to obtain a 0 here as well. So we can basically say row 2, replace it with row 2 minus 2 row 3. 2 row 1. So we have 6 minus 2 by 3, which is 0. Then we have 11 minus 8, that's going to give us 3. And then we have 9 minus 8, that's going to give us 1. And then you have 3, 4, 4. So we have something like this now. And then what we're going to do is we can switch these two columns. And whenever you switch the columns, you basically, remember, you only switch them once, then you distribute a minus 1 term outside. If you distribute them twice, that means you'll have to distribute minus 1 times 2. This is true also if you switch the rows as well. Switch the rows once, then you distribute a minus 1. Switch it again, you distribute another minus 1. So now since I'm only doing it once, I only distribute 1, negative 1. And then I switch the two columns here. And then 4, 1, 1 will become here. And then 4, 3, 2 will be the last column there. And then you have something like this. And then after I do that, minus 3 by minus 1, that's going to give us 3. And then you have 3, 4, 4. And then I basically say row 2 subtract, row 3 subtract row 2. So if I do that, row 3 subtract row 2, then I obtain 0, 0. And this minus this one is technically going to give me minus 1. And then I obtain something like this. And then after that, I'm just going to have 3, since I have obtained row echelon form here. So I'm just going to multiply the diagonal. Then it's 3 times 1 times minus 1. So I have 9 times minus 1, which just gives me minus 9 like this. So that will be the determinant. This basically shows how powerful row echelon form is. Whenever you determine the determinant of a matrix, you can basically use the row operations and get the answer pretty quickly. It doesn't need you to complicate things.